Okay, I am going to start inverse trigonometric functions. Board portion, second year, PUC, board, inverse trigonometric functions. So before going to the inverse functions, we have to know about trigonometric functions. Now we will see what are trigonometric functions, what are their domain and range. Trigonometric functions first we have to do. Then we will convert the trigonometric functions into inverse trigonometric functions. Okay. Now sine function. So domain of sine function and range. Domain and range of sine function. So domain of sine function is you know, in the first year we have studied what is the x value sine can take. So x can take any real number. So here x belongs to R. Sin x, if you take sin x belongs to R. That is any real number x can take. Then what is the range? What is range means minimum and maximum value of the sine function. So that is square bracket minus 1 comma 1. Square bracket minus 1 comma 1. That is the range of sine function. Next let us take cos function. Cos x. For cos x also the domain is real numbers. So any real number x can take. And the range will be always minus 1 to 1. Then the tan function, let us take tan x. So x belongs to real number minus 2n plus 1 pi by 2. So it can take any real number, but it cannot take odd multiples of pi by 2. That is because tan pi by 2 is infinity. So that is not in the domain. So in the domain of tan function, we will have r minus 2n plus 1 pi by 2. What is the range of tan function? It is a real number. It is real number range. So tan can be even 1 lakh, 2 lakhs, 1 million, etc. Tan function value can be anything. So any real number. Now let us take cosecant x. This is the reciprocal of sin x. So when x belongs to R, here cosecant x means 1 by sin x. So sin x, whenever it is 0, those values of x that we have to remove from the domain. So when sin x is 0, all integral multiple of pi, that is we call that as n pi, n belongs to integer. So here we have to write x belongs to r minus n pi, n belongs to integer. So here also n always belongs to integer. Then what is the range of cosecant x? See here, range of sin x is minus 1 to 1. But so range of cosecant x is, it cannot be between minus 1 and 1. So the range is y greater than or equal to minus 1. Y greater than or equal to 1. Y less than or equal to minus 1. So this also can be taken as r minus 1 comma 1. This also can be written as r minus 1 comma minus 1. That is, it will be any real number, but not the numbers between minus 1 and 1 is excluded from the real number. So that is the range for cosecant x. Secant x belongs to r minus again 2n plus 1 pi by 2, n belongs to integer. Now this is also r minus 1 bracket minus 1 comma 1. So cosecant x and secant x, the range is all real numbers except those numbers between minus 1 and 1. All the other numbers you can take. Okay. Now cot x is real number. X belongs to real number minus n pi. N belongs to integer. Real number minus n pi. N belongs to integer. So that is cot x. Okay. Now the y belongs to real. Y is the range. Y is range. X is the domain. Y is the range. So value of the function is from minimum value to maximum value is called range of the function. Now we should be thorough with this. With this basis only, we will be continuing with inverse functions. Now sin x is, again I will repeat, x belongs to R and the range is square bracket minus 1 comma 1. It is also called a closed interval. It is also called a closed interval. Cos x is x belongs to R, but the closed interval minus 1 comma 1 is the range. Tan x is x belongs to R minus 2n plus 1 pi by 2. That is odd multiples of pi by 2. We should remove it from the real number set. Then we will get the domain of tan x. But the range of tan x is any real number. So it is capital R. Okay. Cosecant x is x belongs to R minus n pi. So those values of x where it is integral multiple of pi. For example, sin pi is 0, cos pi, sin 2 pi is also 0, sin 3 pi is also value is 0. Therefore, the cosecant x is 1 by sin x. So 1 by 0 is infinity. That is not in the domain. We should take it is not a number. Infinity is not a number. Therefore, you should take r minus n pi, and the range is always greater than or equal to 1. 1 it can take, but always greater than 1 or equal to 1. And here y is less than or equal to minus 1. Okay, x belongs to secant x, r minus 2n plus 1 pi by 2. Odd multiples of pi by 2. That is cos pi by 2, cos 3 pi by 2 are all 0. Secant x is 1 by cos x. So 1 by 0 is not allowed. So 1 by 0 is not a number. What is that called? Infinity. Infinity is not a real number. So we have to take r minus 2n plus 1 pi by 2. And here r minus bracket minus 1 comma 1. That means any real number excluding the numbers between minus 1 and 1. Okay, this is over. Cot x is x belongs to r minus n pi. In the cot x we have got cos x by sin x. Denominator is sin x. Therefore, all values of sin x where it becomes 0. That is integral multiples of pi. That is n pi. N belongs to integer. So r minus n pi belongs to integer. Y belongs to real number. Okay. Now we will go to inverse functions. Inverse functions. We have defined inverse functions in the previous classes where the relations and the functions, a type of functions, a type of relations. We have already defined the inverse function. I will again define it. A function f from capital X to capital Y is if it is 1-to-1 and onto, 1-to-1 and onto. So we should know about what is a 1-to-1 function and onto function. What is the definition of 1-to-1 function? 1-to-1 function is there is a correspondence between 1-to-1. That is every element is corresponding to only one element from the domain to codomain. Okay, then onto function means all the elements in the codomain are images, all the elements without even one missing. Then if one misses, then it is not an onto function, it will be called into function. Onto function and one-to-one function. One-to-one correspondence should be there for one-to-one function. Okay. Now, if it is one-to-one and onto, then we can define another function that is g from y to x such that g of y is equal to such that g is y to x. Now we have interchanged the domain and the codomain such that the function g is also one-to-one and onto. Function g is also one-to-one and onto. Suppose if you take a function y is equal to f of x, this implies x is equal to f inverse of y. F inverse of y. So f inverse of y function is called that is a g function. G is equal to f inverse of y. G is equal to f inverse of y. This is already we have done it in the previous classes. This is the important point in inverse functions. Using this, we are going to do, you can see f of f inverse of x is equal to f of bracket f inverse of x, bracket f inverse of x. What is f inverse of x? It will be y. So that is equal to x. Like that, there can be one more function can be defined, f inverse of y. This is equal to f of y. F of y. F of y is equal to x. So f of x is equal to y. So these things are there. F of f inverse of x is equal to x, and f inverse of f of y is also equal to y. Now I will transfer this to sine function. What happens is, let us see. Sine of, see, instead of f, we are taking sine function. F is a function. You can take log also. Log is a function. So f function is sine of bracket sine inverse of x. So inverse of x. So this is equal to x. Like that, sine inverse of sine x is also equal to x. Sine inverse of sine y you can take. That is also equal to y. Sine inverse of sine x is x. Sine inverse of sine y is y. This is the steady material in inverse trigonometric function. Now, what inverse trigonometric functions we are going to do is inverse trigonometric functions. That is sine function, cosine function, tan function, and then cot function, cosecant function, and secant function. All these things, how we have to convert sine function as sine inverse function, that we are going to see now. Before that, what is the difference between sine function? Sine function, is it one-to-one and onto function? You underline this. A function, if it is one-to-one, then only we can define another function g from y is equal to x, such that g is also one-to-one. G is the inverse of f. G is the inverse of f function. G is the inverse of f function. In the books, what is the definition they give? They give using what? composition of functions f of g of x is equal to f of g of x is equal to, this you would have done many times, f of g of x is equal to x and g of g of f of x is equal to x, f of g of y is equal to y. So this is the meaning here. Our definition, book definition is they use composition of function, but that does not give us idea for defining sine inverse functions, because the sine function should be one to one and on to. Now we will see the sine function. Okay, I am going to now discuss about the sine function. You can see y is equal to sin x. Y is equal to sin x. I am going to see. Now, this x belongs to R and y belongs to minus 1 to 1. This is called domain. Domain and range. Now, let us draw the graph of sine function. I am drawing the graph of sine function. Sine function, from where to where I am drawing? 0 to 2 pi. 0, this is pi by 2, pi. This is 3 pi by 2, 2 pi. And also, this side also, negative side also I am going to draw. This is minus pi by 2, minus pi, minus 3 pi by 2, minus 2 pi. So, this is a sine graph. Sine graph is, you should understand that the maximum value of sine function is 1 and the minimum value of sine function is 1. So, within this border only, the graph of sine function lies. Is it a one-to-one function? It is it a one-to-one function? No, sine function is not one-to-one in the entire interval. But in some particular intervals, sine function, by reducing the domain, we can convert it into one-to-one and onto function. Now, what is one-to-one function? I will tell you. See, when we draw a horizontal line, if it cuts the curve at 2 points, then it is many to one function. If it cuts the curve at horizontal line, you draw to the curve. If the horizontal line cuts the graph at 2 points, then it is not one-to-one function. So, this sine function, where it can be one-to-one function? Now I will mark this sine function. You see this point and this point, that is minus pi by 2 to pi by 2. Minus pi by 2 to pi by 2. You draw a horizontal line. It intersects the graph at only one point. No. So we take minus pi by 2 to pi by 2 as the principal value of sine function, where it can behave as one-to-one and onto function. One-to-one and onto. Onto is very simple, minus 1 to 1 only. All these values are minus 1 to 1. Therefore, range is always there. That is onto. Because we will have values between minus 1 to 1. All the values will be there for the graph. Therefore, it is onto function. But one-to-one function, we should be careful. Now we can define, I will change the domain of this to minus pi by 2 to pi by 2 and the range as 1. Now, in this area, that is interval, we call that as interval minus pi by 2 to pi by 2. Sin x can behave as one-to-one and onto function. Once it is one-to-one and onto function, we can invert it. And here you can see, not only in this interval, sin x can behave as one-to-one and onto function in the other interval, pi by 2 to 3 pi by 2 also. And this side, it can behave as one-to-one and onto function minus pi by 2 to minus 3 pi by 2. All this intervals, sin x can behave as 1 to 1 and onto function. Now I write the notes for you. The domain of sine function is real numbers. Domain of sine function is a set of real numbers, and the range is closed interval. Square bracket minus 1 comma 1. The range is the closed interval, square bracket minus 1 comma 1. Suppose if you restrict the domain, if we restrict the domain to square bracket minus pi by 2 comma pi by 2, then sine function is 1 to 1. Sine function is 1 to 1 with the range as square bracket minus 1 comma 1. So one interval that we have taken minus pi by 2 to pi by 2, the sine function can behave as 1 to 1 function. But in other intervals also, what are the other intervals? In the graph I have explained that minus pi by 2, minus 3 pi by 2. In that interval also minus 3 pi by 2 to minus pi by 2, pi by 2 to 3 pi by 2, etc. The sine x can behave as 1 to 1 and onto function. So that is very important. Not only one interval. This interval minus pi by 2 to pi by 2 is called principal value. That is called the principal value. The sine function restricted to any of the intervals, square bracket minus 3 pi by 2 comma minus pi by 2 comma minus pi by 2 square bracket comma pi by 2 and a comma, that is pi by 2 comma 3 pi by 2 square bracket, etc. So we can get more intervals, that is 3 pi by 2, 5 pi by 2, 5 pi by 2, 7 pi by 2. All those intervals sine function can behave as 1 to 1 and onto function. Okay, etc. is 1 to 1 and onto with its range as square bracket minus 1 comma 1, square bracket minus 1 comma 1. Okay, so this is the sine function, the discussion about the sine function. Now we are going to make sine inverse function. Okay, now we will convert this sine function into inverse sine function. For that, y is equal to sine inverse of x. X belongs to minus 1 see, we have read in inverse functions, if f is from x to y, the inverse of x, f inverse of y or g function is from y to x. So, we are changing. There it is range, here it is domain. Okay, now, y belongs to minus pi by 2 to pi by 2. Now, let us draw the graph now. Sine inverse graph. Sine inverse graph will be like this. So its value x belongs to minus 1 to 1 only. X, this is x axis. X belongs to minus 1 to 1. Now here we have to mark pi by 2, pi, 3 pi by 2 and 2 pi. Like that here minus pi by 2 minus pi minus 3 pi by 2 minus 2 pi. Here we have to mark like this. Now I will draw the graph. Sine inverse of 0 is 0. Sine inverse of 1 is pi by 2. So the graph goes like this and it will go to pi and it will go 0 and 3 pi by 2 and 2 pi. So like that same way here it will be like this. This is the sine inverse graph and this range is the principal value branch. Minus pi by 2 and this is minus pi by 2. So this area, this graph is called the principal value branch. It will be a S type graph and mark this as y is equal to sine inverse of x and this is the principal value branch. The principal value branch, principal value branch. So let us take this. Now we can I will explain this. You see that the sine inverse and the sine graph x and y interchanges. X and y interchanges. So the x set is domain set. That becomes here minus pi by 2 to here it becomes y set. And here x belongs to minus 1 to 1. That is, it was there for sin x, it was range minus 1 to 1. Here it is a domain. So the graph also from horizontal it becomes vertical. Okay? Because x is between minus 1 and 1 only we have to take. And here we have to take minus pi by 2 to pi by 2. So in other branches also it will behave as inverse function, sine inverse function. In other intervals also we can do it. Now to take down the inverse of sine function. Inverse of sine function is denoted by sine inverse. Sine inverse. It is also called arcsin function. It is also called arcsin function. Inverse of sine function is also called arcsin. Another name for inverse functions, arcsin function. Inverse of cosine function, arccosine function. So be very careful. This you should know. Thus, sine inverse can be defined. Sine inverse can be defined. So in where it can be defined as a function. As a function, sine inverse can be defined as a function whose domain is square bracket minus 1 comma 1 square bracket and the range could be intervals, the range could be any of the intervals. Square bracket minus 3 pi by 2, comma, minus pi by 2. Square bracket minus 3 pi by 2, comma, square bracket minus 3 pi by 2, comma, minus pi by 2, comma, square bracket minus pi by 2, comma, pi by 2, comma, square bracket pi by 2, comma, 3 pi by 2, etc. corresponding to each of these intervals, that is, what are the intervals? 3 intervals I have given example. Okay, there are many more intervals. So corresponding to each of these intervals, to each such interval, we get a branch of sine inverse function. We get a branch of inverse sine function, sine inverse. Okay, the branch with range, square bracket minus pi by 2, comma, pi by 2, square bracket minus pi by 2, comma, pi by 2 is called the principal value branch. The principal value branch. The branch with range square bracket minus pi by 2, comma, pi by 2 is called the principal value branch. Now we can define sine inverse is we define sine inverse as a function from square bracket minus 1, comma, 2 to square bracket minus pi by 2, comma, pi by 2. So we define the sine inverse function as square bracket minus 1 to, comma, domain to range square bracket minus pi by 2, comma, pi by 2. So this completes the sine inverse function. There is some more items are there in sine inverse. We will discuss about that. Sine inverse function that we have completed that definition of sine inverse. You should remember what is the domain of sine inverse of function. It is minus 1, comma, 1, and the range is minus pi by 2, comma, pi by 2. So in other intervals also sine function behaves as an inverse function, but that is not so important. Okay, minus pi by 2 to pi by 2 is a very important one. That is the principal value branch. Now see, I am going to draw both the graphs, the sine function graph and the sine inverse function in the same x and y axis plane. In the same plane I am going to draw this. First sine function. sine function. You know what we have done? This is y area and this is origin. This is minus 2 pi minus 3 pi by 2 minus pi minus pi by 2 pi by 2 pi 3 pi by 2 and 2 pi. So this is the sine function that we have already drawn. Now what is pi by 2 number? It is 1.57. This is minus 1.57. For sine inverse graph, we should take only 1. So this is 1 and this is minus 1. So within that we have to pi by 2, pi 3 pi by 2, 2 pi minus pi by 2 minus pi minus 3 pi by 2 minus 2 pi. So sine inverse graph I am going to draw. Already you know this, how to draw this graph. Okay. This pi by 2 should be somewhere here. Okay, I will change this. This is pi. This is 3 pi by 2 and 2 pi. Here also, this pi by 2 should be here. Okay, this is pi. Let us take this as 3 pi by 2 minus pi minus 3 pi by 2 and minus 2 pi. Now we will draw the graph of sine inverse of x. So it goes like this. It is like this, and here so this graph is y is equal to sine inverse of x, y is equal to sine x, and this line I am doing, dotted line I am doing, this is y is equal to x. Y is equal to x. So very important this one. So yeah, what is from the original function? If you want inverse functions, we have to interchange x and y axis. X and y axis. Suppose if the coordinate of at the original function is a comma b, in the inverse function it will be b comma a. So interchange x and y coordinates, then you will be able to draw from original function to inverse function. So, and another one more thing, every inverse function can be obtained from original function as a mirror image about the line. Mirror image. See, what is mirror image? Reflection. Mirror image. See, you can see this side portion is mingled with this one. It is superimposed. If you fold it, both curves will coincide. That is called the mirror image. So every inverse function is the mirror image of the original function. Every inverse function graph is a mirror image of original function graph along the line y is equal to x. So whenever a curve is a mirror image about the line y is equal to x, two curves are mirror images, then one is the inverse of the other. One function is the inverse of the other. So this is a very important point that we have to consider. So in that, let us take note 1. Note 1. Okay, this is sin x as well as sin inverse of x graph. If y is equal to f of x is an invertible function. Invertible function. If y is equal to f of x is an invertible function, then x is equal to f inverse of y. Thus, the graph of sine inverse function can be obtained. Graph of sine inverse function can be obtained from the graph of original function. From the graph of original function. So, the graph of sine inverse function can be obtained from the graph of original function by interchanging x and y axis. X and y axis if you interchange, you can get the inverse function and the original function. That is, if AB is a point on the graph of sine function, on the graph of sine function, then B comma A is a point on B comma A is a corresponding point on the graph of inverse of sine function. So, if A comma B is a point on, suppose you have A comma B is a point here, then what is that mirror image will be somewhere here. So, these 2 points, if it is A comma B, this will be B comma A. You understand that? So, if A comma B is a point on the sine function, then B comma A is the corresponding point on the inverse graph of sine function. Okay. Next, thus the graph of the function y is equal to sine inverse of x. Y is equal to sine inverse of x can be obtained from the graph of y is equal to sine x, from the graph of y is equal to sine x, by interchanging x and y axis. So what is the first note says? Any function, from the original function, inverse function can be obtained by changing x and y axis. So original function graph, if you change x and y axis, you will get the inverse function graph. Okay, that is the first point. Now there is a second. Note 2 is there. Note 2. It can be shown that the graph of the inverse function, the graph of the inverse function, the graph of the inverse function can be shown that the graph of the inverse function can be obtained from the corresponding graph of graph of original function, corresponding graph of original function as a mirror image, as a mirror image, that is reflection, that is reflection along the line, y is equal to x. Okay, the second point I will repeat it for you. It can be shown that the graph of the function, graph of an inverse function. Take a graph of an inverse function. Graph of an inverse function can be obtained from the corresponding graph of original function as a mirror image or reflection along the line or about the line y is equal to x. So this y is equal to x, you can see here y is equal to x, this is y is equal to x line. So these sine graph and sine inverse graph are mirror images. So this can be superimposed to the other side. If you fold it along the line y is equal to x, both will superimpose. That is called mirror image or reflection. Okay, thank you.